Hello, my name is Robert Smith and I'm with New River Community College's Academic Assistance, and today we are discussing acid and base reactions. Specifically, we're classifying a given species as either a Bronsted acid or a Bronsted base. So let's take a look at them. And by classifying these species as either a Bronsted acid or a Bronsted base, we gain further understanding of what it means to be an acid or a base. So the first example given is hydrochloric acid. And in order to determine whether it's an acid or a base, despite the fact that I just gave away the fact that it's an acid, is by setting up a dissociation equation wherein hydrochloric acid is an aqueous, HCl is aqueous, and it'll split into a proton or a hydrogen ion, aqueous, and a chlorine ion, aqueous. Now, what makes this classified as a Bronsted acid is specifically because it gave up a hydrogen ion. It gave up a proton. You can classify H plus as either a hydrogen ion or a proton, just because hydrogen, all it's composed of is one proton and one electron. The positive charge indicates that it's lost its electron, so it's just a proton. So Bronsted acids are defined as compounds that give up a proton in solution. In other words, because this compound broke off one of its hydrogens and gave it up in solution, that classifies it as a Bronsted acid. So this would be a Bronsted acid. Simple enough. The next one we're going to look at is a phosphate ion, complex ion. So if we were to set up an equation wherein it was in solution, it obviously would not give up a proton because it does not have any hydrogens. So let's set up what could possibly occur in solution. In order to get rid of this -3 up at the top here, we're going to add 3 hydrogens to the reactants, hydrogen ions specifically, and yield a product. So if we took PO4, 3 minus, and then we added to it 3 H pluses. Now, both of these are aqueous. Then we would yield H3PO4, aqueous. And because this phosphate ion is accepting 3 protons, that means that it is a proton acceptor. Again, hydrogen ion can be called a proton. So this is a proton acceptor, which means that this is a Bronsted base. Based on the definition. Again, relatively simple. And I'm sure by now you're starting to identify, just by looking at the compound, whether this is an acid or a base. H2SO4. So if you were to look at breaking this down or putting it in an aqueous solution, where it's either going to combine with hydrogen or separate its own hydrogens. You will see that this one will separate its hydrogens. It'll break off 2 hydrogens in solution. O4, aqueous, becomes 2 H pluses plus SO4, 2 minus. And we can tell it's a 2 minus because there wasn't a charge on the H2SO4 and 2 hydrogens broke off of it. And so we know our complex ion of sulfate is a 2 minus charge. And because this is a proton donor, or because it gave up a proton, we can define this as a Bronsted acid. And that's all there is to it, to identifying Bronsted acids and bases.